Hey friends, welcome to Congruence Tutorials. In this video, we will be learning how to solve a differential equation by using the method called as separation of variables. Now, as this method suggests, as the name suggests, we just have to separate the variables. All the x related variables will go on one side and the y related variables will come to the other side. Okay, so uh, the question will have one term. We'll have all the terms like either in terms of x or y. So into bracket here, like you can see, there's no x plus y or x square plus y square. It's just x, and over here there's just y. Okay, and if we take this one to the other side, as we will do on the next step, will again will be in the terms of only y. So let's see, in this method we can simply separate the x and the y variables and solve them via integration. So let's rearrange the values. Okay, so this one this one that you see will throw it on the other side, so it will become x plus 1 dy by dx equal to 2 raised to e raised to minus y, I mean 2 into e raised to minus y minus 1. Okay, next step is to rearrange the terms. Okay, so this 2 raised to sorry 2 into e raised to minus y minus 1 comes on the denominator on the left side, and this x plus 1 goes to the denominator on the right side. Okay, dx goes to the numerator on the right side and dy stays where it is. So next step, simplify the left hand side. Okay, we have e raised to minus y here, so uh, we'll multiply both the numerator and the denominator on the left side only by e raised to y. So ey here and here, down, up and down both. So we'll have ey at the top next to dy, and this term e raised to minus y into e raised to y will cancel out each other, so we'll just be left with 2 over here, and instead of 1 we have e raised to y, which we multiplied. Okay, this multiplication will apply to both the terms, of course. So let's move on. Next step is to simply integrate both these sides. Okay, so let's integrate. Okay, so e raised to y upon 2 minus e raised to y dy is equal to integration of 1 upon x raised to 1, 1 upon x plus 1 dx. So for the left integral we use the substitution u equal to 2 raised to minus ey. Now this entire term, if we take it u, and differentiate it, the differential will be du equal to minus e raised to y dy, because here we have a minus sign, right? Now, if you observe this term is nothing but this term ey into dy, e raised to y into dy. Okay, so this numerator of the left side integral will become du, and in the denominator we have nothing but u, which is 2 minus e raised to y is u. Okay, and then we have the minus sign. We have this minus sign. This minus sign comes here, right? So minus du, which we can write in this way, equal to integral of 1 upon x plus 1 dx. All right, so now it's very easy to simplify. So we have a log of, or natural log of, u, and u is nothing but 2 minus e raised to y. I've skipped one step mistakenly, but you can write natural log 2 minus e raised to y, which is u, equal to ln of x plus 1 plus c. You can also write down this c as ln of c, right? Okay, so where we were, sorry. All right, so we have this 2 minus e raised to, ln of 2 minus e raised to, I will bring it on the other side. So it becomes ln x plus 1 plus 2 plus ln of 2 minus e raised to y is equal to minus c1. Okay, then using the properties of logarithms, we get uh, this value ln of x plus 1 plus ln of 2 minus e raised to y, we'll get these two terms we can multiply within the bracket and take the entire log. Okay, so let's see what the next step is. All right, so will now deliberately take off anti-log. Right, this is something that we should have done in the earlier step. I again forgot. We can write this term, this c1, as log c. Right, log c. But this c2 is not c is nothing but log of c2. So that anti-log and log gets cancelled. So x plus 1 2 minus e raised to y equal to c. Okay, and this is going to be your final answer. We cannot simplify further than this. Okay, so I hope you understand. Now let's take another example. E raised to x upon y square, sorry, e raised to x into y square plus 1 dx equal to 2y into bracket e raised to x plus 1 dy. Okay, this is our uh, question. First step, separate the variables. As you can see, e raised to x stays here, dx also stays here, but over here we have one bracket which has which has x, right? That is e raised to x plus 1. So we will take this term in the denominator, and this y square plus 1 will go to the denominator on the other side, right? So this is how we get. Next step, again integrating both the sides, we get integral of e raised to x upon e raised to x plus 1 dx is equal to integration of 2y upon y square plus 1 dy. Right? Now, if you observe carefully, the differentiation of this term, this denominator, is the numerator, and over here also the differentiation of this denominator is the numerator. Okay, that's what we have done now. So both the sides are in the standard form, and its solution is ln of this denominator. Okay, this is something that we did in the substitution method in the last sum. We can now consider that to be a standard form. So let's proceed. So we have these two functions, these two integrals. We can write down ln of e raised to x plus 1 equal to ln of y square plus 1 plus ln of c. Okay, so here if we can see, we have taken a constant as ln of c. Okay, so that we can combine all the terms using logarithm properties. So next step, simplify. So ln of e raised to x plus 1 equal to ln of c into y square plus 1. So you can see this term and this term can get multiplied if we take the entire log, okay, using logarithm properties. Then after this step, we just have to eliminate the log, taking anti-log on both the sides. We get e raised to x plus 1 equal to c into y square plus 1, and this is going to be your final answer. So that's about it. Thank you for watching. Please like, subscribe and share, and any kind of feedback is most welcome. Thank you so much, and bye bye.